In this lecture we will discuss how to build star couplers for star topologies, and there are several techniques how to build star couplers, and we will discuss 4 of them in this lecture. We will start with fiber fusion. So star couplers can be fabricated as multi-port fused biconically tapered couplers. It works only for multi-mode fibers, and it is exact same approach as we discussed before for directional couplers. So how does it work? We take 4 fibers, we twist them together, and then we heat the twisted region and until the glass is melted. And once it started to melt, soften and melt, we pull it apart, forming this mixed fusion region where all glass from 4 fibers is mixed together. That is a very nice approach to make simple multi-port passive couplers, and what is shown here is 4x4 star coupler. If we want to build 5x5, we will start with 5 fibers, twist them together, heat, melt, and then pull apart to make a 5x5 coupler. But effectively what we have here, we have a star coupler build, right? So because we have multiple input ports, multiple output ports, and they are interchangeable, and all of them are connected through a single node. Okay, so this is how one way to build a star coupler. Operation-wise, input into any of the ports on the left, for example, port 1, will output equally between 4 output ports 1', 2', 3', and 4'. So ideally the split is equal between output ports, does not matter how many ports we have. Because star coupler is usually designed and we want it, right, to provide uniform power distribution. The previous fusion-based star coupler works only for multi-mode fibers. For single-mode system, we can utilize Y branches, and what is shown here is a 8x8 star coupler. So we have 8 input ports and 8 output ports, and of course they are reversible. And we can build this star coupler, so the whole system, if we, let me write it, so all this, what is inside, I'm trying, right, so all this inside the red figure is called star coupler. What we see outside of the star coupler, it's only fibers sticking out. Okay, using Y branches, we can build star couplers with a different number of ports. What is shown on this slide, it's 8x8, and we will need again 7 plus 7, 14 Y branches to build 8x8 star coupler. Yet another approach to build star couplers is to utilize directional couplers. What is shown here is 8x8 star coupler. So what is I'm trying to encircle, right? What's inside of this circle is star coupler with only fiber coming in and coming out of that box. So how it is built? It is built as shown here using directional couplers. To build, for example, 8x8 star coupler, we need 12 2x2 directional couplers. And light, for example, incoming here to port 1 of the first coupler, it will split. So normally when we build a coupler, we want equal distribution between all output ports. So the directional coupler will be a 3 dB coupler. So for example, for this first directional coupler, the amount optical power coming to the throughput port and coming to the tap port will be the same. So it will be 3 dB couplers. So light will from this port 1 will split between those two ports, and then from this port will go to these two ports, and so on. Overall, we can actually, as we can see, light from port 1, if we follow it, let me follow it. I will use my pen. So let's follow this light incoming from port 1. So it will first go this way and this way. Then it will go this way and this way. And also it will go this way and this way. And from here, you see here it's a 2x2 coupler, so light will continue this way, split, and this way. And it will also continue this way and this way, here and here, here and here. So you see that we started with a single port, and it will eventually be equally distributed between 8 output ports, so we can effectively build a star coupler by using 3 dB directional couplers, 2x2 directional couplers. And the last type of star coupler that we will consider is active star coupler for star networks. Unlike passive devices built using fiber fusion or using Y branches or using directional couplers, those devices are all passive devices. The active star network is not a passive device. It will be illustrated in the figure on the next slide, but I will just say here that it consists inside receivers, decision-making circuitry, and transmitters. So it actually acts like a repeater because it regenerates the signal. So it's much more complex than passive devices that we considered before in this lecture. Therefore, it is way more expensive, but on the other hand, it regenerates the signal, it provides better functionality. But nothing comes for free, right? So the cost is significantly higher. So, and here is a schematic of active star coupler. We have an active star in the middle here, and then we have, for example, for this example, we have 4 stations, 4 terminals. Each terminal can transmit signal and can receive signal. So the transmitted signal then is analyzed inside the active star and will be delivered to all of the other stations simultaneously, if it's a broadcast network, or one at a time, or at will as needed if it's not a broadcast network. That is all for this lecture.